Good morning. It's May 29th, and this is your daily brief in science. Here's everything you need to know. In a groundbreaking study from UC Davis, researchers have uncovered significant differences in the brain development of autistic boys and girls, shedding light on the complexities of autism. This research not only challenges existing perceptions, but also emphasizes the critical need for a more nuanced approach to understanding this condition. Historically, autism research has largely focused on males, leading to a notable sex bias in diagnoses and a lack of understanding about how autism manifests in females. The UC Davis study, published in Molecular Psychiatry, addresses this gap by examining the process of cortical thinning in children aged 2 to 13. Cortical thinning, a natural part of brain development, was found to occur at a more rapid pace in autistic girls compared to boys, with specific differences in brain regions associated with various cognitive functions. The study included brain scans from both autistic and non-autistic children, revealing that autistic females had thicker cortices at age 3 than non-autistic females. In contrast, autistic males exhibited less rapid cortical thinning compared to non-autistic males. These findings highlight the importance of including both sexes in autism research to gain a fuller understanding of the condition. The implications of this study are significant, pointing to the need for further research into how sex differences in brain development interact with autism. As part of the Autism Phenome Project, this research is a step towards more inclusive studies that can lead to better diagnostic criteria and interventions for all individuals on the autism spectrum. The study's emphasis on the unique developmental trajectories of autistic children underscores the complexity of autism and the urgent need to adapt research and diagnostic practices to reflect this diversity. In a recent turn of events, studies have highlighted a worrisome connection between widely used weight loss and diabetes drugs, and the onset of a serious condition known as stomach paralysis. This revelation has sparked a conversation about the safety of these popular medications. The medications in question, including well-known brands like Ozempic and Wegovy, contain semaglutide, a compound that mimics the hormone GLP-1. While these drugs have been celebrated for their effectiveness in managing weight and blood sugar levels, they've now been linked to a series of unwanted gastrointestinal side effects. Among these, the risk of developing gastroparesis, a condition where the stomach is unable to empty properly, stands out as particularly concerning. Further complications such as cholecystitis, an inflammation of the gallbladder, and drug-induced pancreatitis have also been associated with the use of GLP-1 analogs. Reports from patients indicate a surge in symptoms like nausea, vomiting, and GERD, which are indicative of the broader impact these medications may have on digestive health. The findings, which were shared at a recent U.S. conference, underline the critical need for ongoing patient monitoring and additional research. The goal is to fully understand the scope of potential risks tied to the use of semaglutide-containing medications. This situation serves as a reminder of the delicate balance between the benefits and risks associated with pharmaceutical interventions, especially in the realm of chronic conditions such as obesity and diabetes. As the planet warms, trees in the far north are facing an unexpected challenge in their quest for survival, a recent study in PNAS reveals. This research delves into the world beneath our feet, where the symbiotic relationships between trees and mycorrhizal fungi play a critical role in tree migrations, a process now threatened by climate change. The study highlights a stark reality. 35% of tree fungi partnerships, with a notable impact on pine trees across North America, are at risk due to the changing climate. This risk is primarily due to the absence of suitable mycorrhizal fungi in new habitats, which is essential for tree survival and adaptation. Trees rely on these fungi for nutrient exchange and stress resilience, making their role indispensable in the face of environmental shifts. Interestingly, the research found that trees with a broader spectrum of fungal partners tend to have a higher survival rate under harsh conditions. This diversity in mycorrhizal relationships enhances a tree's ability to adapt and thrive in new environments, underscoring the critical nature of these symbiotic interactions. The findings bring to light the urgent need for a deeper understanding of these ecological relationships. Protecting and fostering these connections is crucial for the survival of tree populations as they navigate the challenges posed by climate change. This study not only adds a significant chapter to our understanding of ecological dynamics, but also calls for immediate action to safeguard the future of our forests. In the quest to boost agricultural efficiency, a recent study in the Journal of Applied Ecology sheds light on an unintended consequence: the decline in arthropod diversity and abundance in Chinese rice fields due to the removal of hedgerows and field margins rich in wild grass and flowers. This research offers a critical look at the balance between modern farming practices and biodiversity. The study reveals that traditional farmlands, with their diverse natural habitats, harbor more natural enemies of rice pests compared to consolidated lands. Surprisingly, this increased presence of natural predators doesn't translate to significant differences in pest numbers or rice yields between traditional and consolidated farms. This finding challenges the notion that intensive land use is necessary for high productivity. The researchers propose agri-environmental measures, such as reintroducing flowering plants in field margins, to counteract the biodiversity loss caused by land consolidation. These measures aim to recreate habitats for beneficial arthropods without compromising agricultural output. The study underscores the importance of finding a middle ground that supports both biodiversity and farming efficiency. However, the path forward is complex. The study calls for further investigation into how natural pest control agents can be most effectively utilized across different agricultural landscapes. It also highlights the need for more research on how agri-environmental measures impact yield and labor efficiency in various farming contexts. This research is a crucial step toward understanding how to sustainably balance agricultural practices with environmental conservation. In a groundbreaking study, scientists have made a significant discovery in the fight against rheumatoid arthritis, a condition that affects millions worldwide. By focusing on the activation of a specific receptor, they've opened a new potential pathway for treatment. The research, published in the International Journal of Molecular Sciences, zeroes in on the free fatty acid receptor 4, FFA4, and its role in reducing collagen-induced rheumatoid arthritis, CYA. This study is pivotal as it explores a novel approach to managing a condition that has long challenged the medical community. The researchers' approach involved dietary supplementation with N3-polyunsaturated fatty acids, PUFA, known for their anti-inflammatory properties. They utilized an FFA4 agonist named Compound A, CPDA, in their experiments with mice, comparing results between those with the normal FA4 gene, WT, and those without, KO. The findings were telling. CPDA significantly suppressed arthritis symptoms, immune responses, and pro-inflammatory cytokines in FFA4 gene WT mice, but showed no effect in KO mice. This suggests that the activation of FFA4 is a key factor in the observed benefits. Moreover, the study revealed that activating FFA4 helped rebalance the 1/17 and Treg cells, crucial players in the body's immune response, thereby reducing inflammation and alleviating arthritis characteristics. The positive impacts of CPDA extended to synovial cells and dendritic cell activation, further decreasing inflammatory immune responses. These results underscore the potential of FFA4 activation through N3-PUFAs and CPDA as a promising adjuvant therapy for rheumatoid arthritis by suppressing inflammation and improving immune responses. The implications of this research are vast, offering hope for more effective treatment strategies for rheumatoid arthritis patients. By targeting the FFA4 receptor, this study paves the way for developing new therapies that could significantly improve the quality of life for those affected by this debilitating condition. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.